Hi guys, welcome back to our Chemtube series for A-level students. So it has been quite a while since I uploaded a video, and I think this is quite an important video for those who are sitting for A-levels this year, especially for those who are still struggling to come up with certain concepts in chem bonding. Alright, so this is on covalent character in an ionic bond. So basically, ionic bonds will have a certain extent of covalent character in them. So whether that certain extent of covalent character is intensified or not, it depends on the criteria that we are going to go through now. So basically, when we are talking about the cation, we will be looking at the polarizing power. And when we are looking at the anion, we will be looking at the polarizability. Alright, so when you're looking at polarizing power, there's basically one criteria that sums it up. So it's actually two criteria that I've just decided to put together as one. So it's charge of the cation over the radii of the cation. So in other words, you can actually just call it charge density. Okay, so when I say charge density, it depends on how small the cation is and how big the charge of the cation is. So these two are the contributing factors towards a large polarizing power. So when there's a high polarizing power, it is capable to distort. So basically distort in layman's term means damage. So distort the electron cloud of the anion and pull the electron cloud more towards it. Okay, therefore it kind of shares this electron density instead of just having it as two different entities as such here. Okay, so moving on, for anions polarizability, the criteria that we have got to look out for is the electron cloud size. Okay, the size of the electron cloud. If the electron cloud size is big, then the nuclear charge will not be strong enough to hold on to all the principal quantum shells. Therefore, the electrons are easily distorted and the electrons will then be easily pulled more towards the cation. Okay, so these are two criteria that will actually give you a strong covalent character. So you will need a large amount of polarizing power, large polarizing power. Okay, so and the second criteria, which over here, the large polarizing power is in terms of your cation. And the next one is a high polarizability. All right, so this nature of getting a high polarizability is in terms of your anion. Okay, so with these two, you will get a strong covalent character, which means your ionic bond is being weakened. So in this case, we have an example here. We are going to compare between sodium oxide and magnesium oxide. So if you notice, the oxide anion is the same. So therefore, we'll not be comparing the anion's polarizability since it's going to be the same extent. So the difference here is your sodium element, which is going to form a sodium ion, cation, and magnesium cation. Okay, so if you notice from your data booklet, both of them will be residing in the same period 3. So when we are looking at the radii, it's not going to be so significantly different as well. So we can just say that no significant change in cationic radii. Okay, so in terms of cationic radii, there's no terms that we can compare it to. So finally, we'll just go into the charge. So obviously, when we are looking at charge density, the bigger the charge density, the bigger the charge, the bigger the charge density. So obviously, Mg2 plus has a 2 plus for the charge. Okay, it means the big number 2. And for sodium, is just plus 1. Okay, so the charge plus 2 is much bigger. So therefore, the charge density for Mg2 plus is bigger. So charge density is higher. Alright, so higher the charge density would mean that it has a bigger polarizing power. So bigger polarizing, so in term short form, P power. Okay, so bigger polarizing power means greater covalent character. Alright, so greater covalent character would mean that it is going to have a less pure ionic bond, and therefore the bond strength is being weakened. So bond strength is much lesser. Bond strength is lesser, or you can also say weakened. Alright, so I hope that you understand how a covalent character is determined, because this is a very important concept that will be used in various chapters in Chem. So I hope this video was helpful. Do subscribe to my channel and also like the videos and comment on them so that we can come up with more videos. Thank you.